Okay, we're going to be looking at hypothesis testing, but we're actually going to have to make the hypothesis this time, or form the hypothesis. So I'm not going to read all of this, but I want to go to part A. It says, provide enough evidence to conclude that the average credit card balance has decreased since 2016. Well, in 2016, there was an average of $569. So that means the credit card balance, we want to show that it's decreased. So it's less than that. So we're trying to see that. Less than always goes in the alternative. And then that means the null would have to be greater than or equal to. Okay? Because remember, the less than or the greater than would go in the bottom, or the not equal to. And so since we're trying to prove that it's gone down, that less than part has to go in the alternative. The opposite of it being less than that, well, is that it's still that number or greater. So that is how you would form your hypothesis here. Now, for the critical value, less than, think about less than. Where would the less than be? Well, it's definitely a one tail. And for it to be less than, it would have to be in the left tail. So we are looking at the left side. So we're looking at the negative critical value. So you would just plug that in like we've been doing. Let's see. So the probability is 0, I believe it was 0.05. Yeah, alpha is 0.05. So to get your critical value, remember it's t.inv. Your n, here it was 40 was our sample, so 40 minus 1, your degrees of freedom is 39. So our critical value here is negative 1.685. That part has not changed. The rest of it really hasn't changed. It's just forming your hypothesis. Now, it's negative because it's the less than side. Then you would use our formula that we've been using to calculate your test statistic. So we know that our critical value is negative 1.685. Our test statistic, using our formula right here, you would plug in the values they gave you into the formula. So our sample mean here, it says that the average of credit card debt in our sample of 40 students was 540. So we're going to do 540 minus the mean of the sampling distribution, which is 569, divided by the standard deviation, which is 6725 given to you in the problem, over the square root of n, and n is 40. So when you use that formula, like we've been doing, this is what you're going to get for your test statistic, negative 2.73. So negative 2.73 would be in the rejection area. What are we rejecting? Well, we are rejecting the null, okay? So we would reject the null. There is enough evidence to conclude that it has gone down, okay? It has gone down because if we're rejecting the null, that means we have evidence to support the alternative. So it has gone down. We have sufficient evidence. Does changing the value of alpha from 0.05 to 0.01 affect the conclusion? Well, if we go back and change this to 0.01, our critical value would change to negative 2.426. Well, now this is negative 2.426. Well, we're still going to reject because it would still be in the rejection area even if we changed it. So stay as rejection because the test statistic is less than our critical value. Now, determine the p-value for this test. And I'm assuming we're determining a p-value. I can't remember if we're doing the p-value for the new test. Let's just try it and see. So our test statistic is going to be, we got negative 2.73, I believe, for our test statistic. And then our degrees of freedom, I guess it doesn't matter. We don't need alpha. So our degrees of freedom is 39. And true, yeah, this has nothing to do with alpha. So our p-value is 0.005. Okay, I have not finished question 7, but I will get it started here. The equal and not equal to hypothesis is a little bit easier to set up because you have to look at the question. Does this sample provide enough evidence to conclude that the average house size has changed? Well, the average house size was equal to 2275, so that has to go here. If it's changed, then it will not equal 2275. So it's going to be a two-tailed test, and you could use your Excel to get those values. If it's a two-tailed test, then let's see what our alpha is here, 0.02, and n is 25. So 0.02, and then our degrees of freedom would be 24. So our critical value would be this number negative and this number positive. So negative 2.172 and positive 2.1. And I obviously did something wrong here. 0.02 and n is 24. Let me try that again. I think I used the wrong. Okay, and no, that's not right. Let me try this again too. I was using the right, oh, I didn't select that. The probability would be alpha 0.02 and your degrees of freedom. Let me try it this time. Okay, 2.492. Let's see if that's right. So positive and negative 2.492. It was a two-tailed test. I was using the wrong one when I calculated it. All right, your test statistic. We know how to calculate a test statistic now. And negative 1.82 is going to fall in between 2.492 and negative. Let's just look at it real quick. I'm not going to calculate the test statistic. We've done that a lot. So here's our numbers, and let me see if I have it already written down so I don't have to. So here's our critical value, and our rejection areas are here. But our test statistic, if we were to calculate it using the formula, which I already have done that, I've calculated that for you, is negative 1.82. So let me just scribble that out and start over. Negative 1.82 is going to be somewhere over here, but it's not in the rejection area. So we fail to reject the null. So we do not reject the null. There's not enough evidence to conclude that we can't reject the null, so we don't have enough evidence to conclude that it's changed. Now, it could have changed. We just don't have enough evidence to conclude that. The p-value, so to get your p-value, your test statistic was negative 1.82 and N was 24. So your p-value is 0.041. 0.041. That is, this is a two-tail. So let me see if I can change that for you. You could probably times it by, okay, let's see. Okay, so X and your degrees of freedom, for some reason, I cannot get the two-tail to work. I'm going to try it one more time. Negative 1.82 and then 24. I know when I worked it that I got it to come out, but for some reason I am not able to get it. Maybe I should just try. I don't think I can. Alright, so what I'm going to do is just do the t distribution and get one tail. So that's just one side. So this p-value over here is 0.041. So all of that area is 0.041 and all of this area is 0.041. So if I put those two together, or times 0.041 by 2, 0.041 and 0.041, that would give me 0.082. I'm not sure why I can't get that one to work. I'm thinking I got it when I was working it, but hopefully that will get you started on questions 6 and 7. And I've not finished 8, but I believe 8 is going to be worked the same way. It does give you this t-distribution table, but when you look at the view example, it says to use Excel like we've been doing. So I'm not sure why that's there. The data is here, so you will have to open that in Excel to calculate the mean and the standard deviation. I may work this in the next video just to make sure. It also says test the hypothesis that shoppers spent less than $935.58. So less than would be your alternative, which means your null is going to be greater than or equal to. So hopefully that'll get you started on that one. But let me know if you have any questions.